satellite gets ready to lock on a bright guide star. All changes to the gyroscope spin directions are measured with respect to that star. However, any suitable guide star is relatively close to Earth and would be observed to move. The best guide star for Gravity Probe B, IM Pegasus, is also observed to be clearly in motion. Far better references for Gravity Probe B, in contrast, would be the most remote objects in the universe. Quasars, but they are too dim for the onboard telescope. The solution is to measure separately the motion of IM Pegasus relative to quasars, and later correct for that motion, so that finally the changes to the gyroscope spin directions can be related to the distant universe. 4 different kinds of motion can be measured, 2 relatively large ones and 2 marginal ones. The relatively large motions are the parallax motion as an apparent motion of IM Pegasus relative to the distant background seen from the Earth as it orbits the Sun, and the proper motion of IM Pegasus within the galaxy. Both motions can be measured to distant quasars. The 2 marginal motions are the motion within IM Pegasus due to its binary nature, and the jittery motion due to physical processes like flares on or near the surface of the bigger star of the binary system. The total motion of IM Pegasus in 1 year alone is 100 times larger than the smallest gyroscope spin axis changes measurable with Gravity Probe B. Clearly, this motion has to be determined with high accuracy for Gravity Probe B to be successful. The motion of IM Pegasus is determined with a technique of very long baseline interferometry, or in short, VLBI. This is at present the most accurate technique that we have to determine such motions. The most sensitive radio telescopes on Earth are used to determine IM Pegasus motions. Altogether, 16 telescopes worldwide have taken part in the coordinated VLBI observations. They have observed as a network IM Pegasus simultaneously 4 times a year for several years. The path of the individual telescopes, as the Earth rotates, are used to synthesize a virtual gigantic radio antenna as big as the Earth itself. A 100,000 gigabits of data are processed in each observation. Then the path of the individual pairs of telescopes trace out the dimensions of the gigantic synthesized antenna while the data are analyzed. The results are images of IM Pegasus and extremely accurate measurements of its motions with respect to the quasars. In fact, one of the most accurate such measurements ever made of a star. Gravity Probe B measures the minuscule tilting motions of the gyroscope spin axis with respect to IM Pegasus over the course of a year, and sends the data down to the Mission Operations Center.
At the end of this report, we'll like to switch the FrameX log file. Copy.
Then the path of IM Pegasus itself across the sky is subtracted, so that finally, after years of analysis, the motions of the gyroscope spin axis can be related to the distant universe.